for this question, we are given the equation of three planes. The first two, we know everything of it, but for the third one, we do not know what is exactly A and B. Given that these three planes has a common line of intersection. If so, what is the sum of A and B? We'll do it as usual. We will transform the equation of plane into vector form. Call this is the first plane, second, and the third plane. So for the first plane, we can write as r dot 2, 4, 6 equals to 5. And for the second plane, it is r dot 3, 5, 2 equals to 6. Let this common line of intersection be L. So the direction of L will be equal to, direction of L will be equal to 2, 4, 6 cross with 3, 5, 2. And that is, cover the first row, 8 minus 30, that is negative 22. And cover the second row, 4 minus 18, that is negative 14. We should add another negative for this second entry, so it will be 14. Cover the third row, 10 minus 12, that is negative 2. We can simplify a little bit and say 2, negative 11, 7, and negative 1. So we can pick negative 11, 7, and negative 1 is the direction of L. So now we already set the direction of L. Now we need to find a point on the L. A point on the L will be common for the planes 1 and 2. In order to do that, we can let x to be 0, or y to be 0, or z to be 0. Any of this. So I just let x to be 0. So if x equals 0, 4y plus 6z equals to 5. And this is 5y plus 2z equals to 6. Call this equation 1, equation 2. Equation 2 times 3 minus equation 1. So times 3 will be 15 minus 4 is 11y. Times 3 is 6, 6 minus 6 is 0. Times 3 will be 18, 18 minus 5 will be 13. So y will be equals to 13 over 11. It's not a very nice value, but we just go with it. So from here, from number 1, we know that z is equals to 1 over 6, 5 minus 4y. So it's 1 over 6, 5 minus 4y. So this is 52 over 11. And this is 55 minus 52, that is a 3. 3 over 6, that is 2 here. So it is 1 over 22. And therefore, we can conclude that the intersection line will have this equation. The point that pass through will be x equals to 0, y is equal to 13 over 11, and z equals to 1 over 22, plus lambda of the direction negative 11, 7, and negative 1. Given condition, we know that L is common to pi 1, pi 2, and pi 3. This will mean that L will be parallel to pi 3. L is parallel to pi 3. Then it will mean that the dot product of these two directions, this direction, will be equal to 0. From the calculation, then we know that this is negative 88 plus this is 98 minus a equals to 0. And therefore, a is equal to 10. From the condition, since L is common to 3 of this, so L is actually on pi 3, means that this point is actually on pi 3. So we can conclude that 8 of x, 14 of 13 over 11, A, that is 10, of Z, Z is 1 over 22, is equals to B. So this will be equals to 0. This is equals to 182 over 11 plus a 5. This is equals to B. And this is 187 over 11, that is equals to 17. So now we know that A equals to 10 and B equals to 17 and the sum will equal to 27. So 27 is the answer for this question. This is end of method 1. For method 2, we need a good observation, and I'll show you now. From the given condition, we know that the third equation, that is the third equation, 8x plus 14y plus az, has to be a linear combination of the first two equations. That is, it must be equal to something of 2x plus 4y plus 6z plus 3x plus 5y plus 2z. Now, in order to get the 8 for x and 14 of y, we need to observe that this is 1 and this is 2. When we settle the x and y, the z will follow. So this means that A has to be equal to 1 times 6 plus 2 times 2. That is equal to 10. And this is actually equal to B, and this is B. So B is equal to 1 of 5 plus 2 of 6. That is 5 plus 12. That is 17. So we can get the A and B just using this observation. And therefore, again, the answer for A plus B is equal to 27. And we are done.